In this video we're going to look at when we use the sine and the cosine rules. So you should already be familiar with the sine rule, which is A over sine A equals B over sine B equals C over sine C, and the cosine rule, which is A squared equals B squared plus C squared minus 2BC cos A. So I'll be showing you when to use each of the rules and a few little tricks and interesting things about the rules at the end. So our first question, we have a triangle where one side is 12 meters, one side is 5 meters. We're given an angle of 80 degrees and we have to find out what angle B is here. Now we need to first of all find out whether we're going to use the sine rule or the cosine rule. And to answer this question, we're going to start off by writing down the sine rule. To decide which of the rules I'm going to use to solve the problem, I'm going to first off use my sine rule and tick off the unknowns in the question that we need to find. And in this one we need to find angle B, so I'm going to tick off sine B. Now I'm going to tick off all the sides and angles that we've been given. So if we say that we've got angle B here, then we've been given length B, and I can tick that off. We've also been given this 80 degrees, and I'll say that's A, so we'll tick off sine A, and the corresponding side is 12 meters, so I can tick off length A as well. And you can see what we have here now after our ticking is a block of 4 parts to this equation. And if we have a block of 4 together, it's then and only then can we use the sine rule. And we call this the law of 4. So what we can do then is we can rewrite our sine rule just as before with our values in it, so that we will get 12 over sine 80 degrees equals 5 over sine B. So I want you to rearrange this equation and try and find out what the size of angle B is. So after rearranging, you should have found that B is 24 degrees to the nearest degree. Now we're going to use this law of 4 for another example. So in this example we've got another triangle. We've got length 20 meters, length 50 meters, got 60 degrees, and we're being asked to find the length of x. So again, we're going to write down the sine rule to get us started, and just as before we're going to tick off the start by ticking off the unknown, so the x, and I'm going to say that is side A. It could be any side really, so I'm going to tick off side A. Now we tick off the rest of the information we've got. So opposite to side A, we've got angle A is 60 degrees, so we can tick off sine A. And we've got our 20 meters, so I'm going to say that is side B. And we don't have angle B, but we do have our 50 meters, so I'm going to say that is side C. So if we look at our equation now, we can see that there is no block of 4 like we had in the last equation. So that means that the sine rule doesn't work for this triangle, and so that leaves us with the cosine rule. So what you would do, you would write the cosine rule. So a squared equals b squared plus c squared minus 2bc cos a, and then just as before you can fill in the blanks, rearrange it, and then try and find what a is or what x is in this case. So I want you to give that a go, and we'll check if you got the right answer in a second. So you should have found that a squared is 1900, so that leaves us with a is 43.59 meters to 2 decimal places. So for these two examples, I want you to use the law of 4 and see if we're going to use the sine rule or the cosine rule to answer these two questions. So for question 1, we can tick off angle B, side A, and side C. So we don't have a block of 4 there, so we're going to have to use the cosine rule to answer this one. So for question number 2, let's say that x is going to be side A, and that means we've got been given angle A, we've been given side B, and we've been given angle B, which means we do have a group of 4, which means that we must use the sine rule to answer this question. So now we know which rules to use for which triangle. I'm just going to give you a couple of little tips and tricks that you can use when you're solving these problems. In our first example, I asked you to rearrange this equation here, and it was slightly trickier than it needs to be because you had to move the sine b up and then rearrange everything else around it. You can actually make this easier on yourself by remembering that there's 2 ways that we can write the sine rule. So in one method we have the lengths on the top and the angles underneath, and in the other method we have the angles on the top and the lengths underneath. Now if you are writing down your sine rule, make sure that you've got on the top of the equation the unknown you're looking for. So if you're looking for a length, you'll write it this way. If you're looking for an angle, you'll write it this way. And what that means is that you will be saving yourself an extra step of rearranging. If we have a look at the cosine rule now, we can also write the cosine rule in slightly different ways. Here is the way that we've shown it before, but just by changing the letters around but remaining consistent with our equation, we could write this as c squared equals a squared plus b squared minus 2ab cos c. Now the reason I'm writing it this way is that if we had a right angled triangle, I'll just sketch it here, and so we're looking for C and we have A and B. So this means that angle C is our 90 degrees. And if you type into your calculator cosine of 90 degrees, you'll find it's 0. So in a right angled triangle, c squared equals a squared plus b squared, and since cos 90 is 0, we eliminate this side of the equation, and if you look at our equation that we're left with here, you'll find it's Pythagoras' theorem. So what we can see is that, well, Pythagoras' theorem is really just a specific form of the cosine rule.